Welcome to part 2 of Competency 15 quiz. In this video, we will continue working with mathematical reasoning. Number 6, which one of the following is an example of deductive reasoning? Okay, remember, the difference between deductive and inductive is this. Deductive begins with a statement of something general for that topic. Okay, so A says the first term in a sequence of numbers is 1, the second is 3, and the third is 5. That is a specific sequence. That is not a general sequence. And the big kicker here is it ends with a general formula. So that is backwards from what we need. So mark out A. It is inductive, not the deductive that we are looking for. Let's look at B. The sum of the angles of triangle XYZ and triangle TUV is 180. Those, although letters are general in our minds, those are specific triangles with unique labels being compared. So that is specific to the general. Okay, so that is inductive reasoning, so that's not what we want. Okay, so I'll mark that out. Now let's look at C. All rectangles have 4 right angles. That is a general statement specific to that topic. And let me not use the word specific. That is a general topic for, I mean, that is a general statement for that entire topic. That's what I wanted to say. Okay, had trouble with my words there. All right, so C, because of the words all triangles, I'm going to say that's what we're looking for. That is deductive reasoning. Now, let's see if the next sentence is specific. Since ABCD is a rectangle, it must have 4 right angles. Yes, I would agree with that. That is deductive reasoning. It starts out with the general statement of all rectangles and then it goes straight to a specific rectangle. Okay, let's look at D. Let's see. Line 2 has a slope of 5 and line 1 has a slope of 4. Okay, those are specific lines with slopes. It is not a general statement like rise over run for all lines. Okay, so that isn't what we need. That is obviously inductive reasoning. So let's mark that out. Okay, all right, so let's look at number 7 and 8. Okay, 7. What is the primary purpose of a mathematical counterexample? Well, that's to get the contradiction, to start out with something that's on the contrary, okay? The opposite of. Okay, so A says to adjust our general claim based on the given set of statements. No, we are not. Oh, to justify. Excuse me, not adjust, justify. We're not trying to justify. B, to provide new examples that do not no, you're not just providing new examples. That's not going to work. A counterexample is an example that we know is out there. Okay, and we're trying to use it to help our case. Let's see C. To provide a different approach to solve. No, it's not a different approach. It's a commonly used approach. Let's see what D says. To negate a general statement based on a given set of statements. Yeah, you could say it's a negation. It could be a negation. I'm not quite fond of the word negate. Contradict would be better, but I could see it doing that. Okay, so that makes sense. Yeah, D makes sense to me. That would be, out of all 4 options, D is the best selection. All right, let's look at number 8. Consider the following 3 statements. 1 plus 3 equals 2 squared. 1 plus 3 plus 5 equals 3 squared. 1 plus 3 plus 5 plus 7 equals 4 squared. Okay. Use inductive reasoning, using inductive reasoning, which one of the following statements would apply? Okay, obviously these are very specific, so it is inductive, but now we have to come up with a general formula. Well, before you read your options, it's always good to quickly look at what your observations give you. Well, I see that each of the values is odd, so I see odd numbers. Okay, and then each of them equal. See how there's 2, 3, and 4? This would be, I'm going to write underneath the last one there. This would be n of 1, n sub 1, n sub 2, n sub 3, and n sub 4. So they all have a position. So position 1, 2, 3, 4 would give me, I have 4 positions. So that's 4 squared. The middle one or the second one, it would be 1, 2, 3 positions and they're all odd numbers. So think about this. You have odd numbers, okay? So I would say n squared, okay, where, forgive my handwriting, where n is odd. Okay, that's just my general conclusion, okay, of what I might get. I have an exponential of, or rather a squared exponent, squaring an odd number, whatever, however you want to say it. Okay, so let's read our options. A, the sum of the first n consecutive positive odd integers equals n squared. That fits. However, I'm going to underline it as a possibility. The issue is we need to look at B. Okay, the sum of any consecutive n odd integers equals n squared. Okay, we're going to need to go to talk about any consecutive. Okay, but before we do that, let's look at C and D. And I can tell you right now, those options aren't going to work. Okay, so C says the sum of squares is the first n positive integers equal to n. Well, obviously, that's not what we're observing. That just doesn't go along with what the observation is. Doesn't make sense. So let's look at D. The sum of the squares of any n consecutive odd integers equals, okay, n plus 1? No, that's not what we observe. So C and D can be eliminated because they don't fit with the observation. Now, A we liked right away, but B sounded good too because it had n squared, it had odd integers, okay, and obviously those are integers, okay, and the only thing that I'm looking at is between A and B is one, you need positive integers because that's what we have. We aren't working with negative integers in any way in the example, so we can't say that. And it says any consecutive. So if you took out, let's say you went to the middle of this sequence of numbers, if you went to the middle and only looked at N2, N3, and N4, you're not going to come to the same conclusion, to be honest with you. So any consecutive, and the fact that it doesn't have positive on option B, that would eliminate option B. And naturally, all we have left is A. So A was the best selection. Number 9, a study has shown that the measure of a person's reaction time is a function of the average number of hours of sleep per night. Marcus averaged 4 hours of sleep per night, and his reaction time is 2.5 seconds. Natalie averages 9 hours of sleep per night, and her reaction time is 1.8 seconds. Based on the data and using Y to represent reaction time in seconds, and X to represent sleep in hours. Which one of the following is the appropriate linear model? Okay, getting away from all the vocabulary jargon or the clumsiness of the sentence, which mathematicians love to do, let's look at what we have. We have best fit. It says linear model. It gives us 2 points. 1 point on the coordinate grid for Marcus and 1 point for Natalie. So what do we need to do? Time, which is our hours, will be X. Therefore, it should be in L1. And time in seconds, we're going to stick that in our L2. Okay, so for this, yes, we are going to use our calculator. So push data and data again. Remember, number 4 to clear everything out. Okay, now, so let's put in our hours that they slept. So 4, enter, and 9, enter, arrow over to the right, and then 2.5 for Marcus. 2.5. It took him longer to react. He didn't sleep as much. Okay, then 1.8 for Natalie. She slept more, therefore her reaction time was faster. Okay. All right, now, what do we do next? Remember, second mode to back out to avoid any of those strange errors that might pop up when you're still in the cell. All right, now, we need to go second data to go to our stats, but this is a 2 variable. It has a X and a Y, okay? Because we are creating a linear model. So we need number 2, push enter. It's set up for L1, L2, which is what we need. And now, what do? You can arrow up or down, but I like to arrow up so I get to A and B just a little bit faster. Okay, so A is a negative, which A is our slope. Remember, A is our M value, which is our slope, which is a negative 0.14. So we need that to be negative. Well, automatically C and D are out. Okay. And let's look at A and B. A is missing a very vital component. It is missing the X. So A's out. So negative 0.114X plus, now let's go to our B value. It is correct at 3.06. So yes, option B is exactly what we need. Remember, to get an estimate of a line or any line, you just need 2 points. Now, if information is given down the road, then it'll change, but that's not the question they asked us, okay? This is all we need to do. Short, sweet, and to the point. All right, let's look at number 10. Now, number 10, the colored triangles at the bottom, those are added from me. Just something to help you see it all come out. Okay, so let's read this. Use the figure and the proof below to answer the question of the following. So let's look at the triangles. I see 1, 2, 3 triangles. I see a small one here. Okay, then I see a larger one here. Okay, but when you add the two together, you get something even larger. So that's where I got the 1, 2, 3. But I'm going to get rid of this highlighting because I have this stuff color coded at the bottom. Okay. All right. So let's actually read the question. An algebra teacher presented the proof of the Pythagorean theorem shown above with one missing reason for students to supply. So that means the student has to figure it out. What is the missing reason? Okay, what I see is a proportion, but the way they have this written, it's kind of hard to pick through that. Okay, now there's one thing I need you to see quickly. Right here, they're adding P and Q to make C. Okay, so that's C. Now look at what I have down here at the bottom. The pink triangle is the smallest one, and that has A is the hypotenuse and P is the base. The blue one is the medium-sized one, and that has a hypotenuse of B and a leg or height of Q. Then the green is the largest one, the outside of the right triangle, and that is C is a hypotenuse, B is the larger leg or the height, and A is the base or the smaller leg, which is generally how we present it, A, B, and C. Okay, so now that I've done that, let's take a look here. What did they do? What they did is they used the fact that you have some kind of a label for the original, or rather the larger triangle. And then they showed it is proportional to the small one, and it is also proportional to the medium sized one in blue. And the truth is, all right triangles are similar and proportional. Okay, so they use the fact that we have a proportionality and then they guide along. Okay, so what helps us with proportionality? What does that tell us? Well, if triangles are proportional, then they are similar. If they are proportional, they are similar. So that's where they're going with this. Okay, so I'll go ahead and give you a little extra info on that. Okay, so let's start with what we have. If we use base over height, then this implies what is similar. Okay, well, that gives us P, not height, base over hypotenuse. So I should put high PO because even I mistake that. Okay, so that gives us the letter P over A. Okay, well, P over A, that's a smaller one. Okay, and that gives us equal to which proportion? Well, that would give us C over A, which is the larger one. Okay, so that would be the smaller and the larger. Okay, so let me write that out. A is the base, C is the hypotenuse. Okay, so the smaller the larger. So now we need to make the next connection. Okay, well, that would be the larger one to the middle sized one. Okay, but how are we going to do that? Well, we have to do the leg with the hypotenuse. Okay, so let's see what that gives us. B over, that gives us B over, or no, Q over B, sorry, Q over B. All right, that's the middle one, Q over B. And then for the larger one, of course, we'll have B over A. Okay, so that's the middle one and the larger one. So now we have a connection from the larger one to the smaller and the middle. So this gives us like a logic telling us that they're similar, that the triangles are similar. So let's see what options we have. Okay, A, that's saying C, wait a minute, C, D, B, and B, D, A, B, D, A are similar. That's not going to help you. Okay, because that would be the small to the medium. So A is not going to work. Wrong connection. You have to connect back to the larger one. See what's happening if you try to connect a similarity between the pink one and the blue one, you don't have the right components. So that's not going to help you. Let's look at B. Apply the angle side angle theorem to the triangle BDA, no, that doesn't make sense. That's not going to help us out. C, apply the side angle side theorem. No, that's not what's going on there. They're using proportionality to compare the triangles, which is very convenient because they're right triangles. Okay, let's see here. D, triangles CBA and CDB are similar, and triangle CBA and triangles CBA and CDB are similar, and triangles CBA and BDA are similar. That's what we need. Okay. Notice that CBA is the larger one. So they're saying the larger one is similar to the, let's see, CDB, the smaller one, and the larger one is similar to the medium sized one. Okay. There's a lot of ways to maybe like get mixed up when you're looking at that. But actually, this is the best way to explain it is just quickly jot out the triangles, pull them out, quickly look at them, and then look at what's really going on here. So, verified option D. Okay, all right, this is the last question in this video. Thank you for making it through my little extras and this last explanation. A little bit messy handwriting, but we did get there. And it's truly appreciated for those of you who are liking, sharing, and subscribing. The support is amazing. We'll keep making videos. We will be done with the 4 to 8 TExES very soon, the exam prep very soon, and there will be a workbook out. Don't forget, if you want to print out any of these sections, or you can wait until we have the full workbook ready on our website. You're welcome to go take a look at our website at any time. That would be greatly appreciated. Do not feel obligated to buy anything. The videos will always be free to you. It's just if you buy something, if you really need it and you purchase it, it does help keep the videos coming and the website open. All right, guys, you're greatly appreciated. Thank you very much and happy testing.